Hello, welcome to lesson 5. My name is Opak Mark. In this lesson, we are going to look at the presentation of data. Once the data has been collected, it is displayed in various ways, which makes it easier to interpret and then compare the data. We have different ways. Let us look at the different ways of presenting the data. We can use a bar graph or a bar chart, or we can use a pie chart. We can use a histogram. We can use a frequency polygon. We can use a cumulative frequency curve, or what we call the ogive. Let's see the bar graph or the bar chart. So this is a graph where frequency is plotted against class limit. Let's see how that graph looks like. This is it. We have frequency against class limit, and these are the different bars that comes up as we plot the frequency against the class limit. So that is the shape of the bar graph. Let's also look at the histogram. The histogram, this is a graph where we plot frequencies against class boundary, and in this case we shall have the frequency on the vertical axis and the class boundary on the horizontal axis. So this is it. So we shall plot frequency against class boundary. Let us look at an example which will enable us to see how we come up with that. But before we look at an example, I'd forgotten, let's first of all see how can we use this histogram to plot, also to estimate the mode. How can we use the histogram to estimate the mode? So we're going to look at that using the histogram to estimate the mode. So first of all, let's look at the steps here. That's one, we need to first of all draw the histogram of that data. After that, we are going to look for the model class, or that we are going to look for the model class, and that is usually the longest. We're going to look for the longest rectangle on that histogram. And then after that, we shall join the corners of the longest rectangle to the corners of the adjacent, or to the opposite corners of the adjacent rectangles that are adjacent to the longest rectangle. Let's see exactly what I'm trying to talk about. So here's our histogram already drawn. We are going to look for the model class. This is the model class. The longest rectangle there becomes the model class. That is the model class. Then we get the corners of the model class, of the rectangle of the model class. The longest rectangle, the corners here, these two corners, we need them. So we shall get this corner and then this corner. So for this corner, we shall join it to the opposite corner of the adjacent rectangle. Then this one also will be joined to this corner of the adjacent rectangle. So let us do that. So we have this and that. So where the two lines meet, we shall drop a line from that point downwards, a vertical line downwards, and to that point, and that is going to be read off as the mode. That value is going to be read off as the mode. So that is going to be the mode. Let's look at an example to see how we can do that. So I have this example. That is, the table below shows the weight of senior 4 students of academic year 2018 in TESOL integrated SS who went for medical checkup at Frederica Hospital in Ngora. Use the data recorded below to plot a histogram and use it to estimate the model weight. So here is the data. Then the other question is, what is the mean weight of these students? So for us to do this, first of all, we need to come up with a table. That is the frequency table. Let's first come up with a frequency distribution table. So here, this is the data which has been given. So we want the mean, and then we want the histogram also to get the mode. So first of all, we are going to add these columns to cater for those other questions. that is getting the mean, we need the mid mark and then the f of x. And then for the histogram, we need the class boundary and then the frequency. So I already have the frequency. So let us get the mid mark. So mid mark is here. Then that is the x. Then we shall place our f of x, fx here. Then we shall lastly place our class boundary here. So let's go and look for the mid mark. Mid mark, remember we said for mid mark, we get the lower class limit plus the upper class limit divided by 2. So we shall have 40 plus 44 divided by 2, which gives us 42. And then we shall have 45 plus 49 divided by 2, that's 47. Then the next is 50 plus 54 divided by 2, that is 52. Next is 55 plus 59 divided by 2, that is 57. The next is 60 plus 64 divided by 2, 62. The next is 65 plus 69 divided by 2, that is 67. Then 70 plus 74 divided by 2, that is 72. Then the next is 75 plus 79 divided by 2, that is 77. Then let's go ahead and also get f times x, that is the frequency times the mid mark. So let's start, let's work out this together. Get your calculator and do this with me in order to confirm the results here. So we have 3 times 42, that is 126. Then we have 10 times 47, that is 470. Then we have 16 times 52, that is 832. 10 times 57, that is 570. 4 times 62, that is 248. 5 times 67, that is 335. Then we have 3 times 72, that is 216. Then 2 times 77, that is 154. Let us also get the class boundary. So for the class boundary, you look at the class, and here we have class with the classes do not have decimal. They don't have decimal points. So for classes without decimal points, we just simply add, for us to get the lower class boundary, we subtract 0.5 from the lower class limit. And to get the upper class boundary, we add 0.5 to the upper class limit. So it means that we shall have, for the first class, we shall have 40 minus 0.5 to 44 plus 0.5. So it means we shall have, here we shall have 39.5 to 44.5. So that's what we shall do for all these different classes, and then we get the class boundary. So very fast we can do this. So it means that for this we shall have 39.5 to 44.5. Then the next is 44.5 to 49.5. The next is going to be 49.5 to 54.5. Then the next is 54.5 to 59.5. The next is 59.5 to 64.5. Next is 64.5 to 69.5, and then the next is going to be 69.5 to 74.5, then lastly 74.5 to 79.5. Let us also get the summation here, summation of f. We add this 3 plus 10 plus 16 plus 10 plus 4 plus 5 plus 3 plus 2, that is 53. Then here we have 100. We also get the summation of fx. 126 plus 40 plus 470 plus 832 plus 570 plus 248 plus 335 plus 216 plus 154. That gives us 2951. That is the summation of fx. Let's go and draw the histogram. Now we need a graph paper, so let me get here my graph paper. So that's the graph paper. We are going to draw a histogram. So first of all, let us have the axes, the vertical axis and then the horizontal axis. So we shall leave 1 centimeter here. You can leave 1 centimeter here and then draw the vertical axis. Then also leave 1 centimeter down and then draw your horizontal axis. Now when you look at our data, we are plotting a histogram, so we need first of all, let's label this as the frequency on the vertical axis, and then down here we have the class boundary. Let's start by labeling the frequency here, or marking off the frequency. So first of all, remember that when you go to your table, the highest frequency is 16 and the lowest is 2. So it means that our graph must contain the highest, which is 16, and the lowest is 2. But of course, since 2 is quite close to 0, we are going to start with 0, so that we have 0, 2 like that. Otherwise, you could even start from 2, but if you start from 2, it means that that bar of 2 will mean that it will start at the bottom and it will not appear. So that's why we are going to start with 0, so that we can be able to plot out the 2, or to draw the bar for the 2. So that means that we shall start with 0 here. So if you start with 0, if you look at this, we can, since we have 16, we can say each centimeter is going to be 1 frequency. So we shall have 1, 2, 3, 4 like that for each centimeter. So we shall start with 0, then we shall have 2, 4, 6, 8, then 10, 12, 14, and then 16. So it means that here this will be 3, this is 5, this is going to be 1, this is going to be 2, this is going to be 5, this is going to be 7, 9, 11, 13, and then this is going to be 15. So this is for the frequency. Then for the class boundary, we shall have the lowest class boundary at this point. So our lowest class boundary is going to be there. Then you are going to say that we can say that every class, since the class intervals are the same, or let me say they're all having class intervals of 5, 5, 5, you can take 2 centimeters to represent that class interval of 5, 5, 5, 5. So it means that every class is going to be taking on 2 centimeters. So this means that if this is going to be 39.5 to, and it's going to stop here at 44.5 at 2 centimeters. 44.5 is going to be there. Then we shall have the next is going to be 2 centimeters. Shall leave 2 centimeters again, because we are using an interval of 5, 5 for 2 centimeters. 2 centimeters to represent 5, an interval of 5. So it means that this is going to be 49.5, and then 54.5, and then 59.5, 69, 64.5, 69.5, 74.5, and lastly 79.5. Then after that, we are now going to plot. So let us plot. So the first, we are plotting 3. First class is 3. So 3 is here. The next, so let us first finish up that 3. Then the next is 10. 10, finish up the 10. Then the next is 16. Then the next is 10. So 10 is here. So it means we shall take on this. And then the next is 4. So 4 is here. Then the next is the 5. 5 is this, around here, stops there. So 5. And then we have 3. So 3 is, if this is 2, 3 is around there. So we have this. And then lastly, 2. Lastly, 2. Yeah, so that is the histogram. Then they told us to use the histogram to estimate the mode. So we look for the model class, and that is this class with the longest rectangle. So this is it. So we look for the top and then join the top corners to the adjacent corners, adjacent opposite corners. So this is going to go to this and this to that. So let's do that. So that will go there, and this one also will be here. Then where they meet, we shall drop a bar down. We shall drop, sorry, not a bar, we shall drop a line, a vertical line. It must be a vertical line, so you need to use a ruler and then draw a line, a vertical line downwards. And when you do that, we shall have that line here. At this point, that's where the line is going to be meeting this horizontal axis. So this is going to be the mode. So we need to read off this value here. We need to read off that value. So remember that we say that the class limit, the class interval is 5. So it means that from here up to here is 5. So if you divide 5 by 2, you get 2.5. That means that from here up to here is 2.5. So 1 centimeter is going to be 2.5, representing 2.5. So if 1 centimeter is representing 2.5, so it means we shall add 2.5 plus 49.5, and that will give us 52. So it means that the mode is going to be 52. Yeah. So the model weight is 52 kilograms. Let us also go ahead and get the mean from the formula. You know that mean is summation of fx over the summation of f, where the summation of fx is 2,951 and summation of f is 53. So it means we shall have 2,951 divided by 53, which gives us 55.68 kilograms. So that is going to be the mean weight. Yeah, so that is it for this lesson. In our next lesson, we are going to look at the frequency polygon. Yeah. Thank you for your attention in this lesson. We meet in the next lesson.